Good evening, ladies and gentlemen. My name is Jim Cairns, and I'm your speaker for this evening. This is the third in a four-part series of lectures on innovation. And I thank you for coming, and I thank also Embry-Riddle University for hosting this lecture series. So I'm going to talk to you tonight about a little bit about some of my own experiences and also about how to go about maturing the ideas for your inventions. So I don't know, are there some people here who have not been here before? Okay, yeah, there are a few. So let me just run through this quickly. This figure that you have in front of you is my vision of a roadmap describing the journey from number one up here in the upper left-hand corner through a very tortuous route and finally down here to where you can cash in something on your ideas. So I'll run through this very, very quickly. But, and we're going to talk tonight in detail about this section here of the route. I have, on the first lecture, described this all in a very superficial way. And last time we talked about this area here, which is how to recognize and protect and establish the ownership of your intellectual property, of your inventions. So the route starts up here, as I mentioned, and I recommend that people start by trying to make a list of problems that bother them, things they think they might be able to solve, and then on to step 2 here, where the little guy has found a problem on his list that he really liked and thinks he can solve and goes ahead with that. Choosing your problem gets you through the first gate. In this section here of the route, you try very, very hard to mature the idea as far as you can in your own imagination. Beyond gate 5, in this area here, you subject your idea to various tests to see if it has any commercial potential. And then there's a possible side trip here, which I will not explain tonight, but have explained in the first lecture pretty thoroughly, on how to look for local resources to get some help with your ideas, help with your business plans, possibly even financial help. And then down here, that gets you to this area. Here was a side trip to discuss and learn about intellectual property. This you have to do the first time you go through the route. Then you pass through gate 8 once you're armed with that, and now you have a lot of choices to make here about how to proceed to protect your intellectual property. So you can go directly to a patent professional and have him search, him or her search your technology to see if you have a chance of getting a patent, and then he could file it for you, and that gets you through gate 15. Or you could take this side trip, which we did in the last lecture, to learn about how to search patents online, a very easy way, and then how to do an infringement analysis on the art that you find to see if it's going to conflict with what you want to patent. And if you've done that, you can then, if you go this route, you can then go back to the legal professional, or you can come down here and file the patent yourself. Or you could just start here and come right down here and file it yourself. I don't think anybody should ever do that. You can do it, and people get patents by doing that. I tried it once myself. I never got the patent. But the people in the Patent and Trademark Office, they want to work with a professional. But truly speaking, if your idea has good merit and good commercial potential, you don't want to do it yourself patent, because you're going to have to defend that someday. If it's good, people will be after you. and you need to have yourself well protected. And, once you get through this gate here, that you have your patent, that opens this gate. You come into this section of the trail. You have bandits waiting here to take your money away from you. They're the patent marketing firms that disguise themselves very well. They call themselves sometimes search firms. They have all kinds of names, but they're basically, in my opinion, the ones that you would find advertising are probably all crooks and should be avoided. From this gate on, we will go through, this will be the subject of next week's lecture, but once you go through there, you have a chance here to come and learn about the various ways to cash in on your intellectual property by selling it, licensing it, or whatever. And once you know about the various pros and cons of that, you can come down here to a first point here where you have a patent, you have something you can sell. You know, much you can sell if you just have the deed to your intellectual property, but you have something. And then there are various subsequent steps here that you go through finally to get to the end. Now, you can, of course, bail out anywhere along this route, but you should not do so until you get down in this area. You should not try to cash in until you get there. Because if you do, you're not going to get much of anything for your idea. Your idea is not really worth much, in fact, to be honest, until you get down there. And then you have various ways to cash in. Now let's say, people make often the common mistake of going from the point 1 up here down to 14 where they have a patent attorney. So they get their idea, they go to the patent attorney, files a patent on it, and then they go on their way. You don't get a good result that way. And we'll talk about that a little bit this evening, but I talked about it quite a bit last time. Or worse than that, they start up here and go directly down to the marketing firm, which is a lethal mistake. Can cost you $10,000 or $20,000. You get nothing for your money except heartaches and having your dreams shattered. So anyhow, everybody is an innovator on some level or other. We all are. And you couldn't get through your life, you couldn't get through your daily routine without innovating here and there, just to deal with the little problems that come up along the way. But not everybody is an inventor. I mean, we all do invent too on some level, but I'm talking about the innovator who commercializes the innovation. That's the one I think of as the inventor. And whereas we all have some talents for innovating, we don't necessarily have the talents for being an inventor. That takes a whole lot more diversity of skills to do, business skills, legal skills, and other skills that you can call on other people to help you with, but really you need to have a good handle on that yourself if you're going to make any real progress. So how do you get started? What I recommend is that if you don't already have an invention in mind that you want to if you want to think about commercializing something and you don't already have something in mind, carry a little pad around with you or put it on now your electronic device or whatever, and keep a list of things that bother you, things that don't let you do what you'd like to do or don't let you do them easily, or things that cost more than you think they should, and so on. Just things that irritate you mostly, and problems that you think you might be able to solve. And once that list grows, and by the way, I say to carry something around with you, but you really should transcribe that into a bound and dated journal. If you're like me, you will forget those things if you don't write them down, or you'll lose your little notebook or whatever. So keep right at the outset, get yourself, go down Office Depot or something and get a bound journal with sewn in pages and date those pages as you go. and keep a record of things. So once you have that list of things that you think you might be able to solve, you want to choose one of them. Here at point 2 on the map, you're going to choose one of them to go forward with. You may not make it out to the other goalpost with that one idea, but pick one to get started with. The one you pick should be one whose company you think you can remain enthused with all the way through, because you're going to go through this torturous, dangerous route with that idea. And if you don't have a lot of passion, enthusiasm for it, you're not going to get there. Choose one that's within your financial, physical, and mental capabilities, and also within the capabilities of your family. Because as those of you who are inventors know, that it takes a lot of your time and concentration. It takes time away from the family. So everybody's got to be with you when you go into this. Then I always recommend that when you start out, you start with something that you can at least work with your own hands. That's not always possible. We had a couple here last week who were had a patent on hurricane-proof condominium. So you can't build that yourself. But if it's small inventions, or if it's computer technology or something like that, then you can work on it yourself. And finally, I think you should choose some of the criteria for choosing from your list is that your problem should be simple. The solution should be simple. It should be something that you're pretty sure you can do. And it should be something with which you're thoroughly familiar in your field. I mean, it doesn't mean, it means if you're a cook, it means you're familiar with the kitchen and kitchen gadgets. Or if you work in a auto body shop, you're familiar with tools. It should be something that you can work on with some base knowledge. And one thing I stress at this point as you start out is to not fall into the trap to go, when you get an idea, let's say for your new desalinization plant or something, don't go in to search what has already been done. Try not to look at what other people have done. And I'll tell you why. Because it leads you down, automatically leads you down paths that have already been followed. So try to stay isolated in this first part. Later you're going to look carefully at what other people have done. But try not to do it right away. It inhibits you from your freedom of thought. Pins you down. Well, we're talking about getting started. I have not done this before in these lectures, but people always ask me, so I thought I would take a few minutes and tell you about how I got started. And I'm going to tell you that in this lecture, and then in next week's lecture I'm going to tell you how I went about commercializing it. And I've had a lot of success with a very simple idea. So in the mid-1960s, I was, by the way, I'm an oceanographer and a physicist. Those are my two backgrounds, and my field was physics of the ocean. In the mid-1960s, I had responsibility for an offshore research tower. It was off the coast of California, about a mile or so. And under that tower, there were hundreds of sensors to measure water temperature, salinity, water motion, wave height, all that sort of stuff. And all of those were either buoyed upward from the seafloor around the tower, or they were on the legs of the tower, or they were simply on the seafloor. But every one of them was connected back to the base of the tower by cables, and came up the legs of the tower to the control rooms by cables. And the bloody things didn't work half the time. So I spent, in a few years, I made 1,000 dives approximately under that tower, suiting up tanks, wetsuits, or the hookah rigs, And that is grueling, dangerous, nasty work. It's barnacle-encrusted cables that are sharp as razors and water so black you can't see the hand in front of your face. So I got sick of that. And that was the problem that I identified. I wanted to find out a way to be able to remove those sensors in place and plug a new one back in without dragging all that stuff back up to the tower. So there were a few sorts of underwater pluggable connectors available then, but they caused more trouble than they solved. So I came up with this idea, and it's schematically shown here. If you look at the schematic, this represents a cable. This represents a cable. This is an overmold on the end of the cable. This is an electrical pin whose shaft is insulated and tip is conductive. This is an electrical socket. It's in this gray area, number 3 here, which is filled with oil. Now, the philosophy behind this then is to not try to make the connection in the conductive, corrosive seawater, but to make it in a benign environment that I chose, which in this case was silicone oil. So the way it worked is that this pin number 1 would enter a pre-cut slit here at number 2 in a rubber end seal. It's more complicated than this, but this is kind of what it says. And then it would be wiped clean as it went through that end seal and go down into the oil, and inside the oil it would make contact with electrical socket 4. Now, something has to happen because you're putting a solid material into the oil, so some of that has to be, that volume has to be compensated for, and so here at 5 is a little rubber bladder that went in there, and as the pin went in, the bladder would collapse. And seawater entered into here, but you didn't care. So also as it goes down at great depths in the sea, the oil is at the same pressure as the seawater outside, and so there's no force to push the oil out or suck the water in. Very simple, really simple. But I will say that this was in the mid-60s, and I introduced this idea. Now they're probably on the order of a couple $100 million a year of sales of items like this. And they are on every offshore oil and gas platform in the world. And what these devices did was to allow the modularization of the large systems that go down to complete the functioning of a subsea oil well. So whereas before this time they pretty much had to be hardwired on a out in a dry environment and lowered down onto the wellhead, if something went wrong, the whole thing had to be pulled up. Now this permitted a change in the architecture so that motors, pumps, sensors, valves, any things that were electrically controlled could be changed out on the seafloor. And it allowed operations to go to much greater depths and greatly expanded the global area available for oil and gas production. So I might tell you this story because it's one little idea has had the great impact on one industry. So as I said the other night when we were talking about inventions, don't ever think that your invention is insignificant that you're working on. I thought this was, but you know, it turned out not to be. And many other people, as we said the other night, like the folks at Microsoft and Apple, and going back to Tesla, Marconi, and Bell, you know, they're the people working away in humble circumstances, people like you and me, and they come up with good ideas, and sometimes, I mean, mine has made a minor impact, but sometimes make a huge impact on the industry and the world. Well, once that's the end of my story for tonight, but I'm going back now to the first portion up there at items 1 and 2 on the map. I gave you some criteria for choosing your idea to go forward with. Once you've made that choice, that opens gate 3 for you, and you begin to go along on your journey. Now, between gates 3 and gate 5 is an area where you want to mature the innovation in your imagination as far as you can, without without starting to do anything else. Just work inside your head. The first thing you need to do is define very well what it is that you want your invention to accomplish. If you can't put that down up front, then you're going after a goal that is not precise. So decide what it is you want your invention to do, and then put down those design goals in your bound journal. And you can change them, of course, add to them, take from them, but keep those goals in mind as you go forward. Try, while you're on this route, come in, to, we started at 6:30 tonight, so but you haven't missed much of anything. Oh dear, time out. Okay. You define its goals, and then you decide how you want to achieve those goals, how it's going to work. And then if you have something simple like I did, I was able, for instance, to mold the rubber parts out of RTV that I bought at the hardware store, and cover the pin shaft with something like RTV. And so I put the whole thing together in my garage. And it wasn't anything you could sell to anybody, but it allowed me to understand if it would work or not. So, as I said at the outset, try to get something that you can work on with your own hands. And when you do that, in this period here between gates 3 and 5, you fiddle around with it on your own. So now, once you have set all your goals down, it's time to move this work into what I call your mental workshop. And this is going to be the thing that I most want to talk to you about this evening. And that is working within your mind's eye. Imagination is our faculty for visualizing things within our mind's eye that do not exist, may never have existed, and or might exist in the future. It's our way of imagining a different world. And not every sorry for the distraction, but imagination is, would you mind closing that door, sir? Would you? Imagination is absolutely necessary for us to plan our lives, to plan tomorrow. You've got to kind of imagine what tomorrow is going to be like, or what you would like it to be like. And you need imagination to plan your future. A lot of people don't think about their future so much. But if you cannot visualize a good future for yourself, then your future is up for grabs. It's whatever happens, happens. That's not good. People should have a plan for their future, just like they have a plan for their business. It takes imagination to do that. Well, not all of us have the same abilities at that. Some people have very excellent mind's eye visualization, and other people are nearly blind in that area. So I've given a website up here. It's a lot to try to write down, and these lectures will be on YouTube at some point. But if you're interested in seeing how your mind's eye capabilities compare to other people's, you can go to this site, and it's very informal, but people just comment on their abilities to see things in their mind's eye. And we're going to take some, play around with that a little bit tonight here. The mental vision, like the ocular vision, is different in different people. But if you can't see well with your eyes, you can get some glasses. If you can't see well with your mind's eye, I don't know of anything that can be done to improve that. But I think you can improve the way you use your imagination, and that's what I want to talk to you about tonight. I mean, a lot of people don't do this, and I don't know even if this can be taught, but I think we should talk about it just in case that it can. So I want to look at a couple things with you tonight, and I'm going to ask you to do some things. And let's see, we're very few people here. We're about 30 people here maybe tonight. I'm going to ask you to interact with me a little bit on this. I've put a series of 4 embedded figures here. There's a blue circular disc with a yellow triangle inside of it and an orange square inside of it and a green disc inside of it. Now, I want you to just look at these for a while. And then I'd like you to close your eyes. Okay, just relax now, and I'll keep quiet. And now, if you can recreate these 4 figures in your mind's eye, I'd like you to raise a hand. Okay, I would say about 8 out of 10 people have raised a hand. Keep your eyes closed. We haven't finished yet. Now I want you to keep that image in your mind and let the yellow triangle start rotating about the center of the blue disc. Everything else stays still. And see that triangle begin to rotate slowly while everything else stays still. Now, I'd like a show of hands of how many can do that. Okay, fewer, but still pretty good sample. That's very encouraging. Okay, thank you. You can open your eyes now. Now, this is a difficult setting in which to do this. You're best at this when you're in a quiet environment and by yourself, and not necessarily with your eyes closed. I myself can do this equally well with my eyes open. However, it defocuses everything else. I can either focus on the images in my mind or in the images that I see, but not both at once. Okay. So now, without looking at any figures, I want to describe, I'd like you to close your eyes again. And imagine now a square filled in with purple color. And in the 4 corners of the purple color, in each of 4 corners is a yellow dot. Kind of like looking at one side of one of your dice. And now let those yellow dots move into the center of the square and coalesce into one bigger dot. And then let them spread back out into the corners again. And that is the exercise. And you can open your eyes when you're ready. And again, I'd like a show of hands who could do that. Okay, well, it's a pretty good sampling. I'm impressed, actually. So, well, that's, you can obviously make up exercises for yourself to do this over and over again. And I think that you will find them useful. I know for myself, with the passage of time, I have been able to cultivate my ability to use some mind's eye visualization, but it's such a wonderful tool for inventors that I recommend that you try to do it, particularly if your inventions are mechanical things. I want to try a couple more on you now, and I'm not going to ask you to show your hands or anything anymore, but look at the left hand picture and imagine, you may close your eyes to do this if it helps you, but imagine that you're looking down at your right foot and your shoe's untied. And now imagine those shoelaces moving themselves through the motions that it takes to tie your shoe. Well, curious, can you do that? That's a much harder exercise and probably not easy to do in this environment. But you can see that it's a different sort of exercise because before we were dealing primarily with kind of rigid objects that moved around. Here you're dealing with something that's a little less well-defined. But you can do this if you work on it. I hope you can do it. I want then now to look at the right-hand figure, which is a common wooden clothespin with a spring. And I want to talk to you about the engineering thought that has gone into this simple device. There's a lot going on in this little thing. First of all, it's made of 3 pieces. It has 2 wooden parts which are identical. And so there are only 2 unique pieces, wooden parts and the spring. So the designer has already done something very clever, that he's not made the 2 parts different. So now he can build 1 part and he only has to have half the stuff in inventory that he had before. As we look at it, you can see going across the top on the back here, there's a spring arm that fits into a notch. And there's a flat side to the wooden part, and an opposite side has various details worked into it, one of which is a half a bore here, and some other shapes here, which when it's opened allows the clothes and the clothesline and or the clothes to go in here, and it goes around the clothesline and clips on it. So now, if you were designing this, I think you would, while you're working in your mental workshop, you would envision this clothespin as much as you could. And you would be able, in your mind's eye, hope to squeeze the tail pieces together and watch the jaws open and close. So now you've created an assembly, and you're running that assembly in your mind's eye. The pieces themselves, the making of them is very simple, I imagine. The wood grain goes this way, and it does that because it would break more easily if it ran across the areas that are being stressed so much. Now, the thought that's gone into this has to do with the spring force, the spring shape, because you see it's cleverly shaped. It has a piece down this side that holds these things from moving out to the side. Has a similar piece on the other side that keeps them from moving off to the side. And these notches on either side here keep the pieces from rotating with respect to each other. So it's not so much that I wanted to teach you about clothespins tonight, but to try to encourage you to imagine what sort of thought processes you would go through if you were designing a simple part like this. You take that into your mental workshop and go over it as carefully and as thoroughly as you can. Now I'm going to go a step further and say that while you have this image in your mind of a clothespin, bring that clothespin right up to you. Make it as big as you want. And you, yourself, become a spirit that can move into that clothespin. So you can go into the coil of the spring and look at the springs and see how they interact with the wooden parts. And in your mind's eye, you can travel all around through that assembly. You can make it transparent or opaque or however you want it. It's yours. It's there. You can do with it whatever you want. So you can see that if you have the capability of doing this in your mind's eye, you can advance your design so much further and faster than you can if you're writing things down. So I always recommend to people, don't get your idea up there at gate 3 and immediately start to make drawings of it. Once you set that down in paper, you're not going to want to throw the drawings away. And so when you get rid of the drawings, you've given up your capability to change your ideas quickly and leap from one thing to another. Well, now I'll go one step further yet. You are traveling within this device. Now imagine yourself being one of the parts of this device. Imagine yourself as this upper piece here, for instance. So when I imagine myself being there, this is my face, this is my back, these would be my legs, I guess. But now I can feel this spring force down the middle of my back. I can feel it pressing my face against the other one. And I can feel the pressure of the spring against the under part of my body. This might sound like pure nonsense to you, but I'll tell you, you can do your own stress analysis up to a certain point like this. It's not quantified, but you can see where the stress points are. You can feel those stress points, and you're living your design. Okay, well, I don't know if you find this to be nonsense or not. I've taken a chance going through this evening, but I think it's something that people can train themselves to do. And there's nowhere that I know of where this is taught at all. People basically don't talk about it. I've had a lot of meetings with engineers, design reviews and things, and I try to draw out from the engineers what their actual capabilities are at this. And they're very reticent about it. But it's hard to know what to say, how to describe your experience. Well, I say that you must take your invention as far as you can, absolutely as far as you can, in your mind's eye. And while you're doing this, while you're being part of a clothespin, the people around you will think that you're extremely strange and out of touch with the real world. And they'll be right. You know, when people talk to you and you look at them through those eyes that are staring into space and not, hi Greg. They made it 6:30 tonight, man, sorry. When people are talking to you and you have that stare which is not focused on them, they'll think you're strange, and as I say, they'll be right. One of my heroes is Nikola Tesla, who is, I think, arguably one of the greatest inventors of modern times. He's invented so many things, but the one I mentioned the other evening is that, for one, is alternating current that is powering everything that we're using this evening. I'd like you to just read this quote. He says, "That is the trouble with many inventors. They lack patience. They lack the willingness to work things out slowly and clearly and sharply in their mind. so that they can actually feel the work. They want to try their first idea right off. And the result is they use up lots of money, lots of good material, lots of time, and I would add lots of hope, only to find eventually that they are working in the wrong direction. We all make mistakes, but it's better to make them before we begin. So I just can't stress enough that if you want to be an inventor, you should do your best to try to cultivate this capability. I don't know of any actual tests you can take to test your ability. There are references to them on the internet, and I've looked at them, and I can say that I haven't found anything that was useful. Well, when you have gone as far as you absolutely can in your mind's eye, convince yourself once more that you have eliminated every unnecessary feature or operation of your invention. As you go through this mental imagery, throw out everything that is not essential, everything that is complicated, every little feature that is not useful. Get rid of it, because all of those features cost something. All of those features can contribute to the failure if they're not necessary. Get rid of them. So it's a simple, Spartan designs that are the winners. Now, once again, as you finish your mind's eye work in your mental workshop, now make informal sketches of your invention, capturing all of its salient features. I'm not talking formal drawings here yet. I don't like to make formal drawings or models until the end, because it arrests you at that point. But try to get all of your ideas down and as completely as you can. Now at this point, I give myself permission to go look and see what other people have done. I would not do it sooner. I mean, you're exposed somewhat to what other people have done before you. But now go and see what other people have done. And if you were in the last lecture, you will have seen how to go online and search patents. If you weren't here last week, you can go on the internet eventually and find these lectures. But I will give you one address right now. It's www.google.com/patents. So go there, and a window will open up, a search window will open up, and you put your idea that you know, if you're working on a mousetrap, put in mousetrap, and you'll get 1,000. Actually, one of them won't be mine. Now that I think about it, 1,000 patents that come up for mousetraps. And then take what you can from the art that's out there that is in the public domain. The patent has expired or it's been abandoned, and use what you can. I mean, you don't have to invent something from scratch. All you have to do is invent an improvement to something that doesn't belong to someone else. Edison did that with the light bulb. He did not invent the light bulb. He bought the patent from 2 Canadian fellows who had invented it. And we're out of money and we're not able to really make it work. He made it work. So you don't have to reinvent everything from scratch. The last piece of information on this slide I'm going to give you will also sound strange to you, so I'm telling a lot of strange things this evening, but it's to make a very detailed verbal presentation with whatever, say whatever age you might have, but make it as detailed as you possibly can, not slides. When you have your presentation made, give it to one other trusted person on your feet, standing at a whiteboard or blackboard. And I'm telling you, something different happens when you're standing here or standing there talking to an audience than when you're sitting at your desk. Another gear kicks in. I don't know what it is, but you probably haven't noticed. Mine hasn't kicked in, but another gear kicks in to kind of sharpen your thoughts about what you're saying. I never fail to learn something when I do that. So now you have to be careful, Greg. You have to be careful to whom you give this lecture, because the person could reveal your ideas to others, or worse than that, could come up with an obvious improvement to your idea. And now you're in an awkward spot because you have a co-inventor you didn't want. And that co-inventor will have as much right to exercise that patent as you have. So be careful about that. So I recommend your mother who would be a good one, and she's not completely safe either, because she's likely to be so proud of her offspring that she'll go tell everybody about their invention. But even if you have to do it yourself, something different happens when you're on your feet trying to explain something. So do that. Doesn't take you long, and it works. The next thing we have to do is convince ourselves. Did I skip one? No. Is convince yourself that your idea in fact satisfies a commercial need. Now, I use this patent as an example. This is an extremely useful device. It was invented by a fireman, and if you're in an apartment building, every toilet has a stack that goes up through the building and out the roof so that the system can breathe. Now, you might not like breathing that air, but if you're dying in a hotel that's on fire and you're going to die from smoke inhalation, you would prefer that. So toilets have a trap in them. Water comes up to this level, and if you had this device, you would fish it around through here to where the air is clean, and you would breathe it. I think that's a wonderful invention. I think it was the inventor of this one or one just like it, similar to it, and said, what's going on? Why don't we see your invention around in hotels? He said the hotel industry will not accept it. They do not want to mention anything about bad things that might happen to their guests, so they don't have them. If you travel a lot, you probably should think about putting a piece of hose in your suitcase, particularly if you stay in high-rise hotels. But this is an example of something that's hard to, you could be lured into investing a lot of money in something like this and find out that there's simply a customer rejection of the idea, even if it is a good, beneficial idea. Well, I want to give you some tips now about evaluating your invention. So you've gone through your mental workshop, you've entered everything in your journal, you've made some sketches, and now ask yourself these questions. Can it be manufactured? Now, very skilled engineers I've seen design things that were impossible to build. It's not hard to do. So the first question is, can it be made? This criterion is getting less important as time goes on with 3D, rapid 3D printing. I don't know if you know what that is, but it's basically you print layer of material to form a solid part. And my personal thought is that at some point in the future that will, not too distant future, will obviate many of the operations that are necessarily done now in a machine shop. Anyhow, you can make strange things that way, but be sure it can be manufactured. Try to convince yourselves that it will be widely useful. And will people buy it? I don't know how you do that, but you have to get some feel for the market that you want to enter and the people who are the customers in that market. Do you have the funds and the know-how to develop it? Very important. People bite off chunks that are too big for them and wind up in trouble. And I mentor locally here beginning inventors through the entrepreneurial incubator here at UCF's entrepreneurial incubator. I see people who come to me, not from the incubator, but others who come from the outside, with ideas that are just way out of their league. They don't have the money, they don't have a prayer of making a success, even if it's a good idea. But I used the example in the first lecture. Suppose you come up with an idea for a new valve for a locomotive engine, for a train. Terrific, you know, but you're not going to prototype that in your garage. And you need to not bite into that yourself, but get together with somebody or some bigger organization that can help you with it. Will your potential rewards justify the risks you're about to take? Well, rewards come in basically two forms: personal satisfaction and money. But the risks are a lot more varied. There's legal risks, failure risks, just economy shift risks. There are many, many, many risks. And you can be terribly humiliated, financially ruined, and be in trouble with your family if you happen to get into that situation. So I'm going to have to speed it up a little bit, but will your product be different enough to set it apart from the competition? That's an advantage. It's not necessarily a necessity. But if you have something that stands out, that's unique, it's not just one of 100 things that people can choose from, you're obviously better off. And you can make it unique both through how it operates and how it looks. So you should try to do something to jazz it up a little bit so that people will buy it. The uniqueness that I speak about next has something to do with the patent coverage that you're going to get. Uniqueness is one of the criteria for getting a utility patent. And if yours is not so unique from something else that somebody can buy, yours maybe has a little different widget on the side or something, you probably should stay away from that. Try to get something that really sets you apart technically and from the other stuff. Will it work well in users' hands? I won't say more about that. Will its market be enduring? You know, the old example from, I'm old enough to remember this, but it was the hula hoop, you know, that was a huge sensation. But it would have been fruitless to patent something like that because the market comes and goes like that and it's gone. So before you spend your $8,000 or $10,000 or $15,000 on a patent, think about the lifetime of the technology that you're patenting. Technology nowadays has a lifetime of a few years. I mean, look at your cell phone or your computer, or I mean, those are gross examples, but almost anything in your life changes. What you had 10 years ago, 5 years ago, isn't what you have today. So you've got to be sure that you're going to get a payback in the time frame that before your product is obsolete. Particularly a payback, does it merit filing a patent? Because if you can get something out there on the market, get it to hit, and establish a market position that might last a few years without patenting it, that's a very reasonable decision to make. Serious barriers to market entry. They can be regulations like those imposed by OSHA, by the FDA, many, many other organizations, and also export, the ITAR export regulations. If you're looking for a worldwide market and it's a technical product, you might find that you're not able to export it to a good portion of the world because of the technology transfer problems. Does it require extensive testing? or particularly destructive testing to get it on the market? Do you have to satisfy somebody's rules for product testing? Is there overbearing competition or customer reluctance to change? And I will hark back to my invention that I talked to you about earlier of the oil-filled underwater mateable connectors. It took me a long time to get that sold into the offshore oil industry because those engineers are very conservative and they were reluctant to try a new technology out. The last thing on this list of evaluation is, does it have a simple beauty? And I think you, in your mind at least, your design should be beautiful and it should be as simple as you can make it. Those things are the winners, I believe. Well, going through all these criteria, do you think that these two would be fundamentally good ideas that would have passed those criteria? They were both awarded U.S. patents. The one on the left obviously is an umbrella for walking your dog. I don't know, somebody might have made $1 million on this, but I wouldn't have invested in it. I mean, imagine Fido takes off through the bushes with that thing, or after a cat. I don't know. And the one on the right, again, I don't know whether it was ever successful or not, but this is a cushion to mount on the wall in the men's room above the urinal so that the weary urinator could lean over and rest his head on it. It performs a function. But, and I can imagine, I mean, no disrespect to the inventor, it will work, but if that were my product, I'd be thinking, how many urinals are there in the world, and how many of those would put my cushion over it, and how often would those cushions change, and how much am I going to make on the cushions? And boy, you've extrapolated a huge income from this. I doubt that that ever happened. So be sensible about your ideas, and as interesting as they might seem to you, maybe not everybody needs to lean their head on the wall. Okay, well, we're now down at this point on our map. Sorry. We've advanced it as far, chosen the idea, advanced it as far as we can in our mind's eye. Along this section of the route, we have vetted it by looking at its commercial potential, its manufacturability, and so on and so on. And now we're at this point. And I mention this because there's an opportunity to go off on this little side jaunt here to 6. And I've spoke about this in great detail in the first lecture, and I'm not going to do it again. But if you do go to get some local help at 6, you should do 2 things first. One is that you should file a provisional patent application. And the other one is that you should form some sort of a legal entity, limited partnership, corporation, whatever, but some sort of a legal entity. And then you're able to talk to people about what you have. And so if you go off to 6, the help there consists of small business development centers, which are funded by the Small Business Administration. There are tons of them, almost in every community in the United States of any size. They're free. They must let you enter and talk to them, I guess, if you're a citizen. And their mission is to help you. So they'll help you with your business plan. They'll help you with possibly getting lined up with local organizations like manufacturers organizations and so on. They may help line you up with legal help and so on. So just good places to go. There are the business incubators that I spoke about before. These have clients who reside in them, and they give you all of the help, the assistance that you need. Excellent business guidance, plus all the secretarial, copying, internet, all that thing. They vary all over the country. They're not all the same. There's an excellent one here in Daytona Beach. Through the Small Business Development Centers, or you can go directly to SCORE, which is an organization of retired professionals who work for free and are an excellent resource for you. People of all sorts of disciplines, business, scientific, engineering, whatever. And there is possibility at this point to get funding through what are called the SBIR grants, Small Business Innovation Research, I believe is what SBIR stands for. These are government grants. They are absolutely the finest money that an inventor can get his hands on, because they do not require anything basically in return from you other than that you perform. And particularly they do not require you to dilute your ownership in your business. And they provide you a customer if you get through successfully their program. These SBIR grants come through all departments, like Department of Energy, Department of Transportation. All those have that possibility. So now, whether or not you decide to go over to that route, now you should make drawings in here that are detailed enough to capture every salient feature of your design. And one of the things that those drawings should serve you for is in the filing of your provisional patent application. Now, at this point, I recommend that you do your level best to, first of all, go search patents that are in your area on a Google site or the government patent and trademark office site, and then find some art that is close to yours. If you don't find some, you're not doing a good search. And then take some simple patents that are kind of similar to what you're patenting and study them. Study how they're laid out. They have an introduction, they have a title, they have a background section, they have a specification section where you use your drawings to explain as clearly and comprehensively as you can your invention. Do your very best to prepare your own patent application. Then take it to your attorney or your patent professional, because this gives him something to work with, or her, and provides an entree for you to work with that patent professional effectively. Well, we're getting toward the end, and I'm running a little over time, toward the end of tonight's lecture. I'm not sure what else I can tell you up to this point. I'll just summarize briefly. You've started out by listing your potential problems that you think you might be able to solve. You pick the best one, find a solution for it, the best solution you can. I would say, if I didn't say it earlier this evening, never ever settle for the first solution you find to your problem. Never. There's almost always, I should say, more than one way to solve a problem. And out of that group of ways that you can use to solve the problem, there's only one best way. That's the one you want. So find a good solution. Advance it as far as you possibly can in your mental workshop. Evaluate your invention's commercial potential by going through the list that I gave you. Possibly seek local assistance. Make your detailed drawings, write your draft patent application, and then go see your patent professional. So, sorry, I'm trying to change the slide with my pointer. Those of you who have been to my lectures before know that I always conclude with this slide, which is an invention for kicking yourself in the butt if you don't follow your dreams. I think of all the mistakes you can make, and there are many, the biggest one is doing nothing. So that is the end of tonight's lecture. Thank you.